All right, so now that you've seen the correlation coefficient, you can see how we can make inference with it, I want to bring up three very important misconceptions that people make when they first are, and later actually, exposed to the correlation coefficient. The first one is what I've just mentioned, that the correlation equals 0 implies independence. That's a misconception. It does not. Correlation equals 0 does not imply independence. Second one, this one is very touchy one, and that is that correlation implies causality. It does not. It implies correlation. And the third is this problem with the ecological fallacy that we've just seen an example of. Okay, so let's take them one by one. So here was the example we showed with r equals 0. Things are just, they're just all over the place. You'll get an r equals 0 from this. But you'll also get an r equals 0 from this. Okay, now here we've got a perfect linear relationship on the positive side and a perfect linear relationship on the negative side, and they just cancel themselves out. So if you've looked at the correlation, it would look like that. So this is, you might get with y equals the absolute value of x, you get 0 correlation. So it doesn't mean that they're independent. Here, x and y are clearly not independent. Okay, you give me x, I can calculate y immediately. So they're not independent. Okay, so it doesn't. Now, all right, so this is like a mathematical. Does this happen in real life? Well, here's an example. Okay, so r equals 0 does not imply independence. So here's an example. Now, here's the site where I got this data from. It's at the bottom here. What this is by age groups, and what I've plotted here is I looked at the data about fatal automobile accidents in the US for 2 years, 10 years apart, and what percentage of those fatal automobile accidents had alcohol involved. In other words, when did the driver have an alcohol level of more than 0.08%? 0.08% or greater. And here is the relationship. So we look at this, and first of all, the blue is 1999, and the red is 2009. So in those 10 years, what have we seen? Unfortunately, this is nice. We've seen a decrease here in the less than 16s. Most of those don't have their driver's license, so that's problematic. There's been a decrease in those over 75 and a flat spot in the 65 to 74. But with everybody else between the ages of 16 and 64, there was an increase. There was an increase in the number or percentage of fatal accidents that involved alcohol. So something's going wrong here. That's not why I'm showing you this. It's nice if I give you that message to don't drink and drive. But the reason I'm showing you this is that this looks very much like that relationship we just saw. And in fact, if you calculate the correlation coefficient here, it's not going to be very high because of this strange sort of upside down U shape that we've got. Okay? So that's what linear relationship means. This is not a linear relationship. It goes around the corner. All right? So it's not linear. And there are a number of situations like this where we just have to be very careful. So correlation 0 does not imply independence. So the second one, I said that correlation does not imply causality. And in fact, short of plus or minus 1. So if you've got a correlation of plus 1, minus 1, then you saw that, you know, give me the x, I'll get you the y. So, but apart from that, here's the way Stephen Jay Gould stated it. He said, the invalid assumption that correlation implies cause is probably among the 2 or 3 most serious and common errors of human reasoning. In fact, Pearson said the same thing when he first introduced this. So way back in 1900, he basically said the same thing. All causation, as we have defined it, is correlation. But the converse is not necessarily true. Where we find correlation, we cannot always predict causation. So this has been well established and has gone. Now, we've got to be careful. You see, just because correlation does not imply causality does not mean that there isn't causality there. Okay? This is what the tobacco companies kept telling us for 75 years. Oh, you're seeing correlation. That's not causation. Okay? Here, unfortunately, I just read this. This was actually brought to my attention in the Harvard Crimson. So this is a young undergraduate reporter who points out precisely this. She says, correlation still doesn't equate or equal causation in soda studies. What she was referring to was 2 studies had come out from the Harvard School of Public Health. And one of them linked or showed a correlation between aspartame, is the artificial sweetener in these soft drinks, and increased risks of leukemia, lymphoma, non-Hodgkin's lymphoma. And so that was one study. And the other study correlated high school students who showed that students who identified as heavy soda drinkers were more likely to engage in violent behavior. There are 2 studies that show that. Now, this reporter said correlation still doesn't equal causation. But then, which is quite right, but then goes one step further, and this is where it's wrong. It says, neither study decisively proves, etc., etc., etc. It looks like you're safe to enjoy a glass of your favorite soda. Just because it's correlation, it doesn't mean that it may not be causal. You cannot jump to that conclusion, okay? So it's sort of like a double negative, but it's the contrapositive. You can't conclude that you're safe to enjoy a glass of your favorite soda. Okay? The last one I wanted to mention is the ecological fallacy. There's something, there's a property, it's a mathematical property of this correlation coefficient that when you, let's suppose we do 2 things. We calculate the correlation coefficient just like we did before with the systolic and diastolic blood pressure. So we're doing it on an individual level. We'll get a correlation. Now, let's calculate the correlation coefficient, but not on an individual level, but rather on averages, on aggregates. Okay, so for example, like we have here, countries. So here we're calculating the correlation coefficient between the country consumption of chocolate and the country rate of getting Nobel Prizes, as opposed to looking at each individual and seeing how much chocolate and how many Nobel Prizes the individual gets. Turns out mathematically that this one, when you work with the aggregates, it's much higher than, or I should just say higher, it's higher than if you work on individuals. That is the ecological fallacy, okay? Because here we're looking at correlation of 0.791 between countries' aggregate Nobel production and aggregate chocolate consumption, okay? That's 0.791. It doesn't say anything about the individual. Okay? So the ecological fallacy is assuming that correlations measured at an aggregated level imply the same at an individual level, and the answer is wrong. And here's another huge debate, and that's been going on for a large number of years, and that are people who drink hard water containing higher levels of calcium and or magnesium less likely to suffer cardiovascular diseases. And you can go to the WHO, they've got this whole, I'm not going to waste your time reading it now, but you can go there and you can see. There is one interesting thing, though, because they recognize that the shortcomings of an ecological study, and they're looking for, the next step up is to look at case control studies. And so they look at case control studies and cohort studies to try and settle this argument about this. Now, here's another example of an ecological study, and this is showing the per capita consumption of dietary fat and age-adjusted mortality from breast cancer in different countries. And we see a wonderful, wonderful lozenge, but it's not telling us anything about the individuals. It's telling us on the aggregate level, and the aggregate correlation is going to be higher. We need further study to go into this. Now, once again, though, that's not to say that if there is correlation, that there might be causality there too. And remember, we looked at this. We looked at the mean carries. We looked at mean carries by age, and this was the three studies. The first one was 1971, 74. Then the next was about 8 years later, and then again another 6 years later. And we see that in each age group, the number of carries goes down over those three studies. What was it that was common to all of this was the fact that the water was fluoridated over that time period. And that is how they discovered that fluoride, the fluoride content of the water, helps your teeth. They found that certain parts of the country where the fluoride content was high, people had ugly teeth because that was all mottled and brown and everything, sure, but they had no cavities. So they studied all that carefully, and now we have what we have now. So once again, the opposite, just because its correlation does not necessarily mean that it's not causal also. In fact, it might be the first tip-off, as it was here, to go in the right direction to discover the causal path.